Hello, it's Business Experts Content Channel. Today our guest is Konrad Jeleń.
Hello, Christoph.
Nice to have you in our studio. Nice to meet you.
Thanks for having me.
Konrad is VP of Data Science and AI at Kolomolo. First question, how should a company begins its AI transformation?
It is a very common question to ask. I think the answer is complicated because it...
As AI is complicated.
Well, yes, but democratized now. But I would say it depends.
Okay.
I would say every company, small, medium or large, can perform and should perform AI-based transformation to make use of the benefits that the technology brings. And typically it comes from a fact that the company has identified the opportunity in their business to reduce either bottlenecks in some of their operational processes and reduce costs. Typically this comes from like internal recognition of how the company operates or from the identification of the market conditions that allow for expansion. And then what they should do is first identify the problem to solve, and then either consult an expert or educate themselves. What are the best solutions on the market, standard solutions on the market that can help them overcome this problem?
Okay, so it depends because AI is a beast.
Well, I think I would like to simplify what you just said. I think, first of all, machine learning and artificial intelligence goes back in time, decades, right? It's
decades.
Not. Yes.
Oh, we know about AI for 2-3 years, maybe, and so you said decades.
That is correct. And I think it would help to understand what I mean by decades.
Okay.
And I would start backwards.
Okay.
What happened over the last few years that made your typical Joe on the street think that the AI has just emerged? And that what happened is the growth and emergence of generative AI that is democratized. And I think the best term would be the democratization of artificial intelligence, ability for your typical Joe on their own mobile phone to use AI tools in a very user-friendly way that was impossible years ago. And that onset has brought the artificial intelligence to the common consciousness where you would think that it has just emerged. But before that, before generative artificial intelligence, which is one that you use on the phone, is the ChatGPT, is the Anthropic Claude, is the Copilot from Microsoft and Gemini, of course, and many other. And then you have the video generation tools, and you have the Mid-Journey, the image generation tools. Beyond that, there were systems before that were doing AI all along. They were in the factories. They were used by retail companies, such as one of the cosmetics company that is widely known in Poland, that without forecasting tools, which are machine learning tools and AI, they wouldn't be able to make the margin that they do currently. They are able to optimize the logistics. They are able to optimize warehousing and distribution thanks to the AI, and they were able to do this long before the generative AI emergence. And then you have factories where image recognition, anomaly detection, where automated inspection tools are all based on artificial intelligence. That was the machine vision tools. They were used in military, and they are currently used in military all along.
Okay.
And the tools even that Ukraine uses for the battlefield AI, those tools and those technologies, they were available long before. What happened recently is that the technology to run them, specifically consumer-grade electronics that is able to uphold the workloads that this AI constitutes, it becomes cheap. It costs pennies. I mean, well, not literally, but figuratively. It is affordable to pretty much anyone, up to the point where you can have a disposable drone that does AI recognition of whatever is there in the battlefield that you can get away with.
Okay.
Yeah.
So if AI is known for 40 years?
Since like 70s. I mean, it's been used,
50,
yes.
Almost 50 years. And it is known in business for so long. Why do we now are talking about AI transformation and implementation in businesses?
Well, I will put it simply.
Great.
The way we communicate, you and me and the companies inside, is through natural language. We communicate through natural language. We process natural language in everyday tasks. And most of the workloads that happen to be important in the organizations, other maybe than logistics and retail and, well, many others that simply use numbers and they need to crunch numbers. All the communication and processing is specifically tied to natural language processing. And natural language processing before 2018 was a bit of a chore. So there was AI available. It was used in machine translation. It was used in some basic natural language generation. But it was deficient. It was also expensive. It was expensive to develop. The data sets on which it could have been trained were relatively small. And the compute power available to those AI systems was limited. It is the emergence of many contributing factors, including technology, including the advances in AI, such as the famous 2018 kind of transformation, the famous paper, attention is all you need, and then mathematical foundation for large language models allowed it. And then NVIDIA and CUDA cores specifically, which is the GPU-based processing, that made it possible.
Okay. And you said that it depends how to do it correctly in my company.
Yes, because, well, it depends on scale. It depends on
needs, probably.
Sorry?
On needs.
Yes, those challenges
Problems.
that you face. So one company is going to struggle with logistics, right? So let's talk about one of the companies that I know of, and I have been working with them. They have factory in Targówek in Warsaw. You probably know them. And one of the things that they do is they pack the produce from the factory onto the lorries, right? And they distribute it across the Poland and beyond. And one of the challenges is how to put the produce onto the trucks to make it possible to utilize their cargo space effectively. Another one is how to run a factory such that you wouldn't run out of input raw material as you produce, so that you would have the less stops in your factory that would contribute finally so that you can have the best possible output. Another one is how to predict that your 200 machines, we call them assets in manufacturing, that neither one of them will unpredictably stop working, and then you have the whole manufacturing line stops. Another one is how do I, for instance, process information coming from networks all around the world. Let's say one of my clients has tens of thousands of suppliers of networks and circuits around the world. They provide networking for NATO and many organizations around the world, and they have thousands of suppliers. Okay. And in the geographical locations where those circuits are placed, you would have different events. You would have construction work, you would have interruptions, and so on. And so those suppliers, they would communicate back to the HQ all the information about what is happening with those circuits. You can imagine that this constitutes something in the range of hundreds of thousands of natural language messages back to the HQ in like 24 human languages that someone needs to read and react. And if you were to process it automatically, understand, extract information, this constitutes your natural language processing task. And another client of mine has been processing orders from clients, big supermarkets around the world, in order to send them the produce from the factory. And again, thousands of suppliers, thousands of clients, and they would need to understand those orders written in different forms. Some of them PDFs, some of them natural language emails, some of them Excel spreadsheets and so on, and then understand them and then prepare an order and then fulfill the order. Those are your typical tasks that involve natural language processing. So going back to your question, it all depends on the problem. Identify a problem, identify where that problem costs you, identify how does the cost structure follow revenue, and then identify how can you widen the gap between the revenue and the cost so that you can achieve the best margin. Speaking strictly from like a cost perspective, and also the business opportunities. If you can understand the market better, segment your customers better, produce better products, design and develop better products, and better target your client by understanding your client, then that would mean the ability for you to grow. And in order to do this, again, natural language processing.
And is having a strong IT department or AI manager is enough to successfully implement AI?
Again, this is something that it's been troubling me for some time. So many of the customers that I had did not necessarily have a very strong IT department.
Okay.
And they underwent a successful AI transformation. They were able to embark AI strategy, and they were able to optimally adopt AI solutions that are effectively helping them.
Okay.
The model is different, of course. When you have your own AI, then you have one benefit. You have AI department that understands your business.
And so this is very important.
It's one of the most important things. They understand your business. They understand your data. They understand the processes. They can build things quickly that are meshed with your infrastructure, with your sales, your supply chain, your production, and so on. So it definitely helps.
Okay.
If it is mandatory, no, it is not. Sometimes having a partner who is savvy and can, fill the gap and help you integrate all the systems or some legacy systems or discrete data sources in your organization that are not connected in any way, that is not a very difficult task. It's just a chore that you have to do. And you have to do this with a mindset that this is going to solve a task for you. And that task is adoption of this specific technology to solve your problem. I would say that the companies without overgrown IT have better ability to adopt to the AI than those with the IT that has their own opinion on AI, and therefore they sometimes overcomplicate things that are sometimes not that complicated.
Okay, why it's like that?
Well, I think it becomes from it comes from the fact that when you have an IT, you have your technical debt, of course, which comes from the fact that you've been operating for the last, let's say, a decade.
Yeah.
It comes from the fact that you have standard procedures and standard processes. And then, of course, you have the company inertia when it comes to the ability to integrate the AI solutions into your organization. I can put an analogy for you.
Okay.
You have two countries, one that goes back centuries when it comes to, transformation, industrialization, and development of the modern infrastructure.
Okay.
And then you have another one that starts from nothing. It is far easier for a country that has nothing to embark new technologies like 5G mobile infrastructure than the old one that has to integrate new with the old.
Okay.
And the same goes for the companies. It comes with a challenge, but we as Kolomolo, we help companies to thrive in a sense that we help them to adopt a transformative mindset that allows them to progress their own IT and infrastructure into the AI-driven one.
Okay. What kind of mindset is necessary to use AI tools?
Well, first of all, I think you have to use them. So you need to understand.
Try.
Yes,
First
you need
to try.
You need to try them. You need to use them in order to understand their capabilities. Mindset that is open, where you understand not only the possibilities, but you transform from possibilities to capabilities, including limitations. You understand what is the best tool for the job. So education is key. One of the key things I think I have met in my professional life, and we as Kolomolo, we met in our experience with our clients, is that very shallow understanding of the AI and a sort of following the hype, which is something very common now when you have all the market pressure and stakeholder and shareholder pressure for AI to be slapped onto the company logo to, make the company AI enabled because, well, that boosts your
image.
Yes, it boosts your PR.
Okay.
You have to have the ability to really understand and give yourself the time. Then there's the maturity in the technology adoption. AI has to be understood as yet another technology that allows for rapid adoption of the new paradigms, but it comes with limitations. When you think about it as an adoption roadmap, and you have done adoption in the past, like other technologies like business process management systems, like very common now, robotic process automation, like RPA, and CRM systems that are now commonly used for sales, and master data management, like large databases and lakehouse and data warehouses and so on. All of those were promising technologies that had their time. They were emerging, and you had to learn how to adopt them. You had to understand that this is the moment when we freeze our capabilities that we accept from this technology, and then we start piloting them in a very disciplined way in a company. What this mindset requires is the discipline that we put together a roadmap that is supposed to achieve a certain outcome. We have to understand that we will make mistakes. First of all, we will fail several times in some of our assumptions, in some of our approaches, but the initiatives that we put onto our roadmap, they need to be simple enough, they need to be impactful enough and short enough so that within the time span of development of this initiative, we can achieve some measure of success. Last year's Gartner report was stating about the AI emergence and AI adoption in the companies around the world. It has stated that over 50% of all the AI initiatives are stopped without finishing them. Someone came up with a concept for a project. They were developing it, and then in the middle, someone decided, oh no, something next happens. It's like, a new car. We are just ditching that one. We're buying a new one. Never really adopting AI technology, always in this POC mindset. This is wrong. You have to be disciplined to get things to their end. And then 85% of AI initiatives in the companies never make it to production. So out of 50% that are not stopped, 85% do not make it to production. And from those that are in production, over 50%, well, less than 50%, never achieve the outcomes, the return on investment that the management was originally looking for, which means that you have to understand that those initiatives are initially potentially high risk. But if you have a partner, potentially us, Kolomolo, or if you have a mindset in your organization that allows to pick and choose the business challenge to solve, and then specifically target specific technology and be disciplined to use it and deliver. Of course, you have to be agile, but it doesn't mean that you stop midway and then change everything. Then you have a high chance to overcome the key components that Gartner has specifically listed as those that drive failure.
Okay, but to use AI effectively, you first need to understand
capabilities.
Yes, and how it actually works. Could you explain in simple terms how modern AI systems operate behind the scenes now?
Of course, I think that this bit is a bit of a black magic to some people. One of my favorite authors, Arthur Conan Clarke, once said that any sufficiently advanced technology is indistinguishable from magic, and I think this holds. And I would say you have to understand at least some of it. In principle, when we are talking about modern AI, we probably are talking about one that has been democratized, available to us at our fingertips. And we are specifically targeting generative AI. What it does, and you have to understand this, is it produces a prediction of the next most probable word. Okay, so you put a sequence of words into what we call a context, and then what this language model does, it keeps producing next most probable words until it reaches the stop, and that's it.
Nothing special.
Well, when you think about
no black magic.
Well. In a sense, no, because what we call those systems, like the large language models, we call them autoregressive systems. And autoregressive systems have been in the AI machine learning world available to all of us for the last decades. But they just worked upon different principles. They were your predictive systems. They were predicting your sales in the horizon of the next 2-3 days, months, or years. They were used for the weather prediction. They were used for rainfall prediction. They were used for crops production prediction with seasonal or trend characteristics. The same goes for large language models. They just use different technology for predicting the next word. And you may have heard about this technology. It's called transformers. It's been widely known. We, however, using that technology, have a kind of perception that this isn't true. When we put one text into this AI, it tells us one thing, and then when we do this another time, it tells us something slightly different. How does this happen? You said, Konrad, it's fully deterministic. Yes, that is correct. Those AI systems, the LLM, the machine, the large language model, is 100% deterministic. There's nothing random about it. Absolutely nothing random. The only thing that it does is when you put a sequence of words into it, let's say a paragraph of text or your question, it spits out 50,000 buckets, each one of them addressing specific, we call them tokens, but you can simplify this saying words, stating that this and this word are most probable. It attributes, let's say, word great, let's say 45%, and then attributes another one, less so, 36%, and all of those words, they combine up to 100%, which means, the full thing. And then what happens next is the random selection engine that picks up from those words that were predicted, one that should go next. And it does so with the help of a parameter that some of the listeners would know from operating the AI, temperature. The higher the temperature, the more randomly the system outside the large language model picks up the next word, which means it adds a little bit of variety to the answers given to you by the model.
So AI can't think, it only uses words?
It is. The answer to this question is complicated, right? Because it goes to the theory of mind and, of course, what the thinking process is. But in a nutshell, I don't want to take all the time in the world to explain all of it, but in a nutshell, the mathematical foundation for how the large language models are built is the transformer layers that essentially build upon abstraction over abstraction over abstraction of the mathematics that drives the selection of the next word. They build this very complicated mathematical machinery that has an emergent property that resembles thinking, which means it processes information in such multi-layered way that it results with the words that follow a logical chain of reasoning structure that gives you the next word that is a logical consequence of the previous words and a sort of model that was trained on how a human being should think.
And we think that we chat with ChatGPT.
We do. And there could be nothing...
Think, but we do not chat.
That is correct. I mean, this is a common misconception, I think, specifically important for parents who deal with their children who are convinced, and in some cases, following Arthur Conan Clarke, that there's some magical being that has a soul with whom they have interaction. Nothing further from truth. Every single time the model performs the computation, it has to be specifically stated, computation. It does a computation of the previous sequence that results with the next sequence that is the consequence of the previous one. Stop. And every single time when you put a paragraph of text, your question, your biggest dream or your aspiration into the chat, and you get an output sequence, that's it. The session is over. The model doesn't do anything. It's idle, and it doesn't know you.
Okay.
And the next time you put another chat, the whole previous history of conversation goes into as the input sequence to produce another sequence.
And
you can think about it
once again.
Yes, everything starts once again. Just having more input at the start to begin with. And then you can think of it as if every single time it is a different person answering a phone, reading your previous conversation, and then following it up with their own thoughts, being trained on the same principles, on the same books. Yes, we as human beings, like to think that this is the same entity that is talking to us, which is absolutely not true.
Okay.
It couldn't be further from true.
But it's only our imagination.
Of course it is. We like to attribute meaning to things that we deal with.
But AI tools can be taught.
Can be trained.
Can be trained by RAG. R-A-G.
That is far-fetched. So there are two aspects of that paradigm that you have just mentioned that would need to be separated. Okay? So first of all, the training. What we do with the model before we embark on any question answering or generation, if you will, which is the actual term that we use in our field for producing the next word, most probable word. There's the training of the model. The training of the model happens over trillions of words that are extracted from books, posts on the internet, videos, and so on, that are available to researchers and those who create models through a common data set known as Common Crawl. It's available to everyone.
Okay.
And models are trained on patterns, on how the generation should happen. And then there's a next kind of training of that model. It's called supervised fine-tuning, which actually teaches the model through a process or a branch of AI known as reinforcement learning. And there's many algorithms like direct preference optimization or group policy optimization that are currently most common ways of fine-tuning the model to do what we want. And this is specifically training a model that knows how the language works, how to do tasks, like how to answer a question, how to reason, how to give best answer, how not to be harmful, how not to give false answer, and so on. And that is the original training. This is typically up to a point where the model was trained on some data, and we call it cutoff. So this is pre-training. This is where you get the model that's been trained on something. Then follows the conversation. The conversation that we put into the context, so that is the questions and answers and different phrases or prompts, paragraphs from books or from PDF documents or the PDF documents themselves, they form the context. And they fall into the context window that is typically limited, is driven by the model architecture. Within that context window, through the process of consuming each and every next token, which you can attribute this to be, for the sake of our conversation, a next word, the model formulates understanding or
Logical.
Yes, understanding in my field we say statistical distribution, actually Bayesian statistical distribution of what this conversation is all about. The model understands the key features of this conversation. And by features, I mean not something that we as human beings can understand. Those are like themes of this conversation. This person is talking about George Orwell. This person is talking about modern government. This person is talking about books. And there are thousands upon thousands of those different features that you haven't explicitly mentioned. They are also the emotions, they are the tone, and so on. And then when it produces the next word, the next word has to fall into that distribution. And we call this paradigm of learning in-context learning, ICL. And it is the actual scientific term for learning. And then there's RAG. So what RAG does, it is a very well-defined umbrella term for techniques that help the language model put into the context relevant information that the model hasn't been trained on. So as I said before, the model has been trained on something like a common crawl up to a cutoff, let's say 5th of September 2025, which means it knows nothing that happened after this November 2025. And what RAG allows for that model is to operate on the knowledge and facts that stretch beyond that cut-off time. How? By accessing a database of facts that you give it. And that database of facts is the retrieval part. So what the model does, in addition to the large language model, because the model doesn't know how to access database at all, we build additional systems, RAG systems, that help model to understand that it has access to database, so that model can ask the tool to give it some knowledge, and then we retrieve from that database most relevant information. How? Well, there's few techniques. One of them is simple query. We know SQL systems like SQL, where we can formulate a query to the database and just pick a record that is most relevant to our query. That's fine. Better way, specifically attributed to natural language, is a similarity retrieval system where you take a large document, let's say a book or your legal case, and then you chunk it, which means you break it down into smaller pieces. You put it into a database known as vector database. And then before you put this into a vector database, you do a mathematical operation called embedding. What embedding does, it attributes to every chunk the semantical vector, which is a bunch of numbers that describe those abstract terms that help you to understand this paragraph of text in terms of what does it mean. Those vectors or those embeddings are a byproduct of model training, the one that I said before with the cutoff, which means as the model trains, it builds something called embedding layer, which understands the text, understands the semantic structure of a text. It understands that word king is different in the context of Burger King and different in the context of the prom king, from in the context of a bowl, and then king in a historical context, right? Those are different semantic contexts, and they have different vectors. And what we can do is we can have this conversation or a question, we call this query, in large language models. And what we do is we perform mathematical operation called similarity evaluation. It is using a matrix calculation and trigonometric functions, cosine function. It's called cosine similarity, to find how close is your query to that specific paragraph. And it uses very efficient way in searching relevant paragraphs in that database to pull one that is important to you. And then it drops it into the context and makes it relevant so that the generation can continue knowing now the fact that was relevant to you. And then there's the latest paradigm that's been like adopted by the industry. It's called graph RAG, which instead of using the chunks of text, it uses what is called a knowledge graph, which means those are concepts connected by relationships into a large network of concepts. We call this entity a graph, knowledge graph. And then what the large language model can do is it can walk over that graph and pull your important node, let's say paragraph, from this graph along with the surrounding context. And then it has much better understanding of the whole context. It can be context rich. That's the term that we use. So this is where the RAG comes in. And answering the initial question about learning, it's not learning unless you mean in-context learning, which I did address before. It enriches your context and allows you to have, for the organizations, the ability to produce the outcome, the next word or the next paragraph, or classification of text, for instance, or it can extract information from text based on this enriched context. Does that answer your question?
Yes, I think so. But probably there are some errors in AI applications. And mistakes.
You probably mean the infamous hallucination, correct? Very true. I would say it is a misconception. So hallucination is by design. Okay, it is by design built into the large language models. It is undesirable by us human beings, but from a mathematical perspective, everything is absolutely fine. From our undesirable perspective, it is that the model generates tokens that do not make logical sense, or they make logical sense. I mean, they follow some reasoning pattern, just not related to our query.
Okay.
And it is actually more harmful because it looks like real. And from the model perspective, it is as real as the other. And it comes from a fact that in the absence of data points, things that the model has learned in the past that are related to your query, the model doesn't have this statistical distribution that allows it to produce with very high confidence tokens that are relevant to you. So it produces still the mathematical distribution of most probable words. They are just not related to your question. In order to combat this, to limit the hallucination, there are several techniques that are used. And just for the sake of the listeners of this podcast, I would say the most important one is RAG. It combats very efficiently the hallucination such that it occurs, according to research, approximately 5% of times, still 5%. There are other techniques that are being used in this natural language processing and in common business tasks in order to reduce it even further, up to the point where it becomes almost irrelevant or on par with my hallucination and your hallucination, which we do every day.
So prompt is also very important in using AI.
Very, very important. I think I will try to make this a little bit more scientifically grounded to help listeners to understand and perhaps maybe adopt best techniques.
Great.
So maybe I need to do a step back.
Okay.
For the emerging AI paradigm in business, there's been a lot of companies being essentially built, consulting companies, engineering companies that have slapped on AI logo on top of their company logo in order to make use of the AI efficiently. And in many cases, that is a bit of a snake oil. And I think this is that dangerous area for big players on the market to choose the best partner to work with so that they wouldn't sell them snake oil. And many of those companies or many AI enthusiasts, they perceive the prompt development or prompt engineering, because that's the term, as an art where it is not. It is actually science, and it is driven by science. I said before about the in-context learning.
Yes.
So in-context learning builds, if you think about it, a statistical distribution of your context that is full of certain features, characteristics of this conversation that make generation of the next word more accurate and more in line with the whole conversation. And think of prompt as priming this statistical distribution and effectively making in-context learning more efficient. And there have been developed techniques for building of this perfect prompt and perfect prompting techniques for certain tasks, because we have different tasks that are good with one task and worse for other tasks, and vice versa. And so there's been a number of techniques for prompting developed and evaluated, and there's scientific papers available on ResearchGate and other prominent AI papers sources that actually show you the actual benchmarks and how this is driven. But there's been techniques like zero-shot prompting, one-shot prompting, or few-shot prompting that talk about building a query and then adding some examples, one or many or zero, for your given problem. And then there's been techniques like tree of thought or chain of thought or chain of drafts and many others that are best in some cases and in some tasks and worse with others. And there's techniques to optimize those prompts to make them best for your organization. And now, speaking to business leaders, I would say you don't have to, in many cases, rely on this black art of perfect prompt crafting and maintenance, because once you've built your system, you have a bunch of prompts that you have to maintain, which means you have to change them in time with examples and so on. You can do this automatically. And Stanford, as the university in the US, has been wonderful enough to share with the world a bunch of techniques and algorithms for optimization that help you to automatically build prompts best for the task. That library and that technique is called, the library is called DSPY, and techniques for optimization are, for instance, MyPro, which you may look up and they may work for you. This helps organizations to scale their AI systems with prompts without the need to do all the context, to do all the complex prompt engineering and maintenance.
Okay. You often talk also about context window. How can businesses use this concept effectively to improve the quality of AI outputs?
This is a very important topic, by the way, and there's so much I would like to talk about, but I will try to make the gist out of it. So I would say this. The context window is effectively the operational memory of your large language model. It's the maximum amount of text that you can put into the large language model, not before it breaks. Just full stop. The maximum number of tokens that you can put into the context window until you cannot put anything more. Because the architecture of this model, the technology behind, simply cannot take more.
Okay.
And the context window is typically now, with the modern large language models, is somewhere around 200,000 tokens, up to what Gemini offers, the Google model, 1 million tokens, and I think they have done recently some more. And it is something available to you. Now, when you are a company and you think, wow, that's a lot. I mean, 200,000 tokens, that's more than a book, right? It's a few books until you exhaust this context window. And then I would say, not so fast. You have to be careful with this. This is the maximum number of tokens. It's like you were told, this is the maximum amount of text I can read in one night. It doesn't mean that I would understand and remember all of it, right? So this is where the complication comes in. Within this context comes the phenomenon that's been explored by Chroma Research. It's one of the companies and research institutes that does research in AI, that they have attributed with the term context rot, like deterioration, right? And what it means is that once you start packing tokens or words into your context, at some point, the ability for AI to reason and to give you coherent, high-quality output peaks. It's like the best. Then it goes into plateau, and then it drops like jumping from a cliff, which means there is a point at which that context is just not going to work for you anymore. And because of this, emerging engineering paradigm appeared that is important for my listeners, our listeners, and that is context engineering. And this means that in the AI systems that you have to put in place in your organization, you have to implement technical paradigms that help you maintain that sweet spot. Be at this, 10,000, maybe 20,000 tokens tops, and not more, because after that, you're done. The quality of answers, the ability for the model to fulfill the task, like to classify email as, for instance, a maintenance notification email or anything REST, is just jumping from the cliff. And those context engineering techniques are very well defined. One of the fathers of modern AI, Andrej Karpathy, wrote in one of his famous posts on the X, the formerly known Twitter, that context engineering is actually much more important than the prompt itself and prompt engineering. And for the companies to achieve excellence with their AI solutions, they have to be aware of this. And they have to implement techniques. Fortunately, there are several techniques that are well documented. They are well defined as best practices. And my recommendation for the listeners is don't invent your own stuff. Look for best practices that have been used over and over on the market, that have yielded best performance. And those context engineering techniques, just to give you a gist and understanding, are, for instance, summarization. So you had a long conversation, you're approaching that moment when it jumps from a cliff. So what do? You just summarize what was there in the context into a much shorter paragraph, perhaps maybe 1,000 to 2,000 tokens long, and then you can continue with that previous conversation summarized. You can put some important facts into a database and then remove them from the context programmatically. You can do many more things, like remove from the context completely irrelevant facts. Because what you can do mathematically, you can evaluate your context because there's a known thing. You have it at your disposal at all time. You can analyze it, find in that context information that is completely irrelevant when you were talking about your cat in the context of processing invoices, and then just simply remove them.
You give some advices for CTO or IT director, but how to start using AI. Where can he or she find some help?
Thank you for having this question. I would say this. You don't have to do all the things yourself. It could be a daunting task to learn all of this yourself. And sometimes the best is to have someone to help you, someone who's an expert. And we, Kolomolo, are such experts. We have 6 strategic services to help organizations to embark successfully on the AI journey. And there are a number of other companies in the region that can help you also. But I would say do not be afraid to get the help from experts.
To ask.
This is why you have the companies that specialize specifically with the know-how, experience, deployment, development, and lessons learned, that they have done those mistakes before, and they have a much better chance of getting you on the right footing.
Okay. Is Kolomolo worldwide?
Yes. We operate primarily from Poland and Sweden, but we have also built our presence in the US, and we are expanding towards Germany and DACH region. So we are available to you whenever you need. Please
wherever
check.
you are.
Yes, please check www.kolomolo.com or contact me directly, ai@kolomolo.com.
Okay. Another hot topic is multi-agent. How can companies practically benefit from them?
Well, this is an emerging phenomenon in the business and technology world. And I would say this, first of all. It's not a new thing now. It has been well-defined, very well-defined. And I will first explain the concept. So I will start from a problem. The problem is that you have a conversation with the AI in one window that goes over and over. And as I said before, every single time you talk to your language model, it needs to process not only what you just said, but also all things that were said before. It's a lot of tokens. It's a lot of cost. It's very inefficient. And when you've primed your conversation with the prompt initially to solve a specific task, and you're changing the task in the meanwhile, you are deteriorating the context coherence. It is no longer about one task. It is about 2 or 3 or 4 tasks. And because of this, the performance of this model will drop because there's so many tasks in the same context.
It's too much.
It's too much. It's like when you were given 5 different tasks to do. I mean, there are some people that are very efficient with this. I am not one of them. And my wife says that I can only work at one thing at a time. And that's very true as a man. So what we do is we try to solve this problem. We try to have the LLM that is efficient, a sort of chat that is efficient, and communication between next tasks in a very efficient way. So what agents are simply separate chats that are specifically attuned to one specific task. Okay? When the
one man, one task.
Yes.
One chat, one task.
Yes. So when the task is solved, typically in 1 or 2 goes, then the result of this task is an artifact, for instance, a document, a record in a database, image, and a summary of what the agent has done. And for the next agent or next chat to begin their work, they don't have to get the whole conversation from before, which is very inefficient. It's a lot of tokens. It's a lot of cost.
And time.
And the companies would need to know this. Instead, you get the gist of the previous conversation, you put it as a context for another agent, plus the task that this agent is supposed to do, and it does its own thing. So multi-agent systems are effectively those separate chats that communicate via a very efficient channel, which is just a summary of what was done before, in order to solve a complex task that is comprised out of many tasks. So long story short, that is it.
Okay. Coming to the end of our conversation, I would like to ask you if a CTO or IT director is just starting to explore AI implementation, what would be your key advice for him?
I think I would have 3, key things. Yes. Okay. One is adopt fail fast mindset. You will fail. Many things will not work as expected. Be ready for this, right?
Be prepared.
Second is start with the things that are important and can be done quickly. Gartner report says that projects that span beyond 6-7 months risk a high failure rate because of early cancellation. Almost all 18 months plus projects were cancelled. Okay. So build things and decide on the business problems to solve that can be solved in a short period of time. What we offer, for instance, as Kolomolo to our clients is a 90 days chunks of solutions that prime the organization for early adoption of AI so that you can line them up into 90 days chunks or slivers of work that deliver value. So adopt this mindset, do work in iterations, target your problems that are important for your organization that give you the return and motivation to do more. And the third one is education. You have to adopt the AI solutions and understand their capabilities and limitations. Working and developing your AI programs and AI strategy based on hype, market pressure, stakeholder and shareholder pressure, and changing the solution just because something new, better came up is the best way to fail.
Okay. So education is very important.
Yes.
I hope our conversation would be a bit of education for listeners.
There's a company in Poland, I think they are called Campus AI, that actually offer educational services, empathetic educational services, and we offer empathetic AI strategy to our clients so that we can work with you to build strategy for you as an organization to adopt this mindset and then to build those solutions.
Is there anything we haven't touched on today you would like to add? Or
I would say, and this is important. AI is not new. It's been there for decades, and it will be there. It will be developing further and further and taking its rightful place in the business strategies. And the more you learn how to work with it and how to benefit from it and learn its limitations, the more you will be able to be successful in your job. And I think that's like the most important thing that I would like to say.
Our conversation is for 1 hour. I think it is very interesting. It was very interesting for me. Thank you.
Thank you.
And I hope it was also interesting.
My pleasure.
For our viewers and for our listeners. It was BETS Podcast, Business Experts Content Channel. Thank you for today and see you next time. Thank you.
Thank you, Christoph. Thank you for having me.
Thank you.